The Strait of Hormuz is the most consequential 21 miles of ocean on Earth. Every day, under normal circumstances, approximately 20 million barrels of crude oil and petroleum products pass through this narrow channel between the Persian Gulf and the Gulf of Oman, representing roughly 20% of the entire world's oil supply and an even larger share of global liquefied natural gas exports. The nations of the Persian Gulf, Saudi Arabia, Kuwait, the United Arab Emirates, Qatar, Iraq, and Iran itself depend on this corridor to export the hydrocarbons that fund their governments and sustain their economies. The economies of Europe, Asia, and the developing world depend on the uninterrupted flow of energy through it. When Iran closed the Strait of Hormuz in the hours after Operation Epic Fury began on February 28, 2026, it was not merely a military act. It was a weapon aimed at the entire global economy, and countering it fell primarily to the instrument that has been the cornerstone of American maritime power for 80 years, the Carrier Strike Group. Within hours of the first American and Israeli strikes hitting Iranian soil, the Islamic Revolutionary Guard Corps transmitted warnings over VHF radio to vessels in and approaching the strait, declaring that no ships would be permitted to pass. The threat was credible. Iran had spent years developing an asymmetric maritime warfare strategy specifically designed to control or deny the strait without requiring a conventional navy capable of defeating American carrier-based air power. The strategy relied on a layered combination of anti-ship missiles fired from mobile coastal launchers, naval mines scattered across the shallow confined waters of the strait, fast attack watercraft armed with rockets and machine guns capable of swarming merchant vessels, and one-way attack drones increasingly capable of hitting surface ships at ranges exceeding 300 kilometers. Within days of the warning, tanker traffic through the strait collapsed by more than 90%. Oil tankers from companies including Maersk and Hapag-Lloyd were ordered to avoid the region entirely. Crude prices jumped more than 12% in the first week, approaching $81 a barrel, with analysts warning of $100 or higher if the disruption persisted. The International Energy Agency launched its largest ever emergency reserve release. 230 loaded oil tankers sat in the Persian Gulf, unable to exit. The economic damage was the largest oil supply disruption since the 1970s energy crisis. The United States Navy's response to this crisis was anchored by a concentration of carrier-based air power not seen in the Middle East since the 2003 invasion of Iraq. The USS Abraham Lincoln, designated CVN-72, a Nimitz-class nuclear-powered aircraft carrier, had been operating in the region since January 26, 2026, having transited from the South China Sea after a deployment that began in November 2025. The Lincoln was carrying Carrier Air Wing 9, which included F-35 Charlie fighters from Marine Fighter Attack Squadron 314, FA-18E, and F-Super Hornets, EA-18G Growler electronic warfare aircraft, E-2D Hawkeye airborne early warning aircraft, and MH-60R and MH-60S helicopters. As early as February 3, 3 weeks before the war began, an F-35 Charlie from VMFA 314 had shot down an Iranian Shahed-139 drone that had approached the Abraham Lincoln in the Arabian Sea, a sign of the threat environment the carrier was already operating in. When Operation Epic Fury launched on February 28, Lincoln-based aircraft participated in the opening strikes on Tehran, Esfahan, Qim, Karaj, and Kermanshah. The Lincoln and her strike group were positioned in the Arabian Sea, south of the strait, placing their aircraft within range of the full depth of Iranian territory. The second carrier to enter the theater was the USS Gerald R. Ford, designated CVN-78, the Navy's newest and most technologically advanced supercarrier. The Ford had been ordered redeployed from Venezuela to the Middle East on February 13, joining the Lincoln in what became the first dual-carrier presence in the CENTCOM area of responsibility in nearly a year. The Ford transited the Suez Canal on March 4 and 5, with photographs released by the Pentagon showing the carrier and its escort destroyer, USS Bainbridge, passing through the canal. The Ford then took position in the Red Sea, placing her air wing within range of Iranian targets from the west, while Lincoln covered the southern and eastern approaches from the Arabian Sea. This two-axis positioning was deliberate. Iranian air defense planners faced the problem of a carrier to the south and a carrier to the west, creating overlapping strike envelopes from multiple directions that no single orientation of Iran's defensive network could optimally address. The Vice Chief of Naval Operations, Admiral Jim Kilby, told the Senate Armed Services Committee that the Ford's extension would result in an 11-month deployment, breaking the post-Vietnam War record of 294 days set by the Lincoln herself in 2020. The Ford carried Carrier Air Wing 8, which included the Tomcatters of Strike Fighter Squadron 31, the Reagan Bulls of Strike Fighter Squadron 37, the Golden Warriors of Strike Fighter Squadron 87, the Black Lions of Strike Fighter Squadron 213, and the Gray Wolves of Electronic Attack Squadron 142, operating EA-18G Growlers from Naval Air Station Whidbey Island. The Ford's strike group included the destroyers USS Winston S. Churchill and USS Mahan, with USS Bainbridge accompanying the carrier through the Suez Canal. 4 additional destroyers, USS Roosevelt, USS Bulkley, USS Oscar Austin, and USS Thomas Hudner, were operating independently in the eastern Mediterranean, giving the Ford strike group a wide geographic footprint. The scale of the naval buildup continued to grow as the campaign progressed. A third carrier strike group entered the picture when the USS George H.W. Bush, CVN-77, completed its composite unit training exercise off the coast of Virginia on March 6 and departed Naval Station Norfolk on March 31 for deployment to the CENTCOM area of responsibility. The Bush was heading to relieve the Ford, which had been at sea for over 9 months, and had experienced a significant shipboard fire on March 12 that injured 2 sailors and damaged internal spaces, eventually requiring the Ford to transit the Suez Canal and put into port at Split, Croatia, for repairs and crew liberty. The arrival of a third carrier strike group represented the largest concentration of American carrier aviation in the Middle East since the opening of Iraqi freedom. Secretary of Defense Pete Hegseth had signaled this buildup weeks earlier, stating that incoming American and Israeli forces represented multiples of current deployments, a deliberate message of strategic resolve aimed at Iran. The naval component of the campaign extended well beyond the carriers themselves. 6 Arleigh Burke-class guided missile destroyers were operating independently in the Arabian Sea as of the first week of March, supplementing the escorts organic to the carrier strike groups. The destroyers USS McFall, USS John Finn, USS Milius, USS Delbert D. Black, USS Pinckney, and USS Mitcher provided additional Tomahawk strike capacity, air and missile defense, and surface warfare coverage across the vast ocean areas surrounding the strait. 3 littoral combat ships, USS Canberra, USS Tulsa, and USS Santa Barbara, were based in Bahrain, with the Navy's first operational mine countermeasure mission packages in the 5th Fleet area, specifically configured to address the mine threat that Iran was deploying in the strait. American attack submarines operated covertly throughout the theater, and on approximately March 3, a United States fast attack submarine using a single Mark 48 torpedo sank an Iranian warship in the Indian Ocean, the first submarine sinking of an enemy surface vessel since World War II. The destruction of Iran's naval forces was one of the campaign's most complete achievements. Vice Admiral Brad Cooper, head of United States Naval Forces Central Command, stated in the first week of operations that the Navy had destroyed more than 30 Iranian naval vessels and had put a hole in the side of Iran's most operational submarine. He described the carrier strike groups as squeezing the Iranians and having them back into their own ports. By March 19, CENTCOM confirmed that over 44 Iranian vessels involved in mine-laying operations had been destroyed. Not a single Iranian naval vessel was underway in the Persian Gulf, the Strait of Hormuz, or the Gulf of Oman as of the first week of the campaign. Iran's Islamic Revolutionary Guard Corps claimed on March 5 that it had struck the USS Abraham Lincoln with 4 ballistic missiles and drones in the Sea of Oman, a claim that American officials categorically denied, with CENTCOM stating that the missiles did not come close and releasing photographs showing the Lincoln conducting flight operations with no damage. The mine threat proved to be the most persistent and difficult element of the maritime campaign to address. Iran had seeded portions of the strait with naval mines, and by late March it had emerged that Iranian forces had lost track of some of the mines they had planted. The New York Times reported that Iran was unable to fully open the strait even after ceasefire discussions began because it lacked the capability to locate and remove all of the mines it had deployed. The United States Navy's mine countermeasure assets, including the Littoral Combat Ships equipped with mine hunting and neutralization packages, along with underwater drone systems confirmed by CENTCOM to be part of the clearing effort, began setting conditions for safe transit through the strait. On April 11th, 2 United States destroyers transited the Strait of Hormuz, the first American surface warships to do so since the war began, and CENTCOM confirmed they were beginning mine clearance operations. President Trump simultaneously posted on Truth Social that the United States was starting the process of clearing out the Strait of Hormuz, framing the operation as a freedom of navigation assertion and a step toward restoring the global oil flow. The strategic logic of the American approach to the Strait of Hormuz combined offensive and defensive elements simultaneously. Offensively, the carrier-based air wings and the independently deployed destroyers and submarines systematically destroyed Iran's ability to project power in the maritime environment. Every Iranian fast attack boat capable of threatening tanker traffic was a target. Every coastal anti-ship missile battery was a target. Every mine-laying vessel was a target. Every IRGC naval facility capable of sustaining maritime operations was a target. The A-10 Warthog was credited with hunting and killing Iranian fast-attack watercraft inside the strait itself, and the AH-64 Apache provided overwatch against surface threats close to the Iranian coastline. The carrier air wings provided the sustained strike capacity that could prosecute these maritime targets around the clock without the range and endurance limitations that would constrain land-based aircraft. Defensively, the carrier strike groups and the independently deployed surface combatants provided the air and missile defense architecture that protected both American forces and, increasingly, commercial shipping in the region. Iran's retaliatory strikes targeted not just American military assets, but the civilian infrastructure of American allies throughout the Gulf. The United Arab Emirates saw its Dubai International Airport temporarily suspended after drone strikes. 6 Iranian drones and 21 missiles were intercepted over the UAE in a single engagement. Qatar, Kuwait, Saudi Arabia, Bahrain, and Iraq all faced Iranian missile and drone attacks. The destroyers equipped with the Aegis combat system and standard missile interceptors provided the long-range missile defense coverage that protected both naval forces and allied population centers from the hundreds of ballistic missiles and thousands of drones that Iran launched throughout the campaign. By April 12, peace talks between the United States and Iran were underway in Islamabad, Pakistan, led by Vice President J.D. Vance, Jared Kushner, and Steve Witkoff. The reopening of the Strait of Hormuz was described as a central topic of those negotiations. 3 oil supertankers had transited the strait in what was described as the biggest day of oil exits through Hormuz since Iran closed it, representing a tentative restoration of the corridor. But the strait was still not fully open, and Iran was described as restricting and conditioning transit by demanding payments and safe passage fees from vessels. The blockade had not been definitively broken. The naval campaign to make it so was still in progress, with American forces continuing to operate in the theater, a 3rd carrier strike group arriving to relieve the ford, and additional amphibious-ready groups, with Marine expeditionary units converging on the region. The story of how the United States Carrier Strike Group became the instrument of choice for this kind of maritime power projection requires understanding not just what the Carrier Strike Group is today, but how it became what it is. It is a story that begins in the depths of the Second World War, passes through the Korean War, the Cold War, the nuclear age, and the post-Cold War era of American maritime dominance, and arrives at the 21st century with a platform that has been continuously refined over 8 decades into the most powerful conventional military force ever assembled around a single ship. To understand what a carrier strike group is, you first need to understand what the aircraft carrier at its center represents. A modern American nuclear-powered aircraft carrier is the largest warship ever built by any nation in history. The Nimitz class, 10 ships commissioned between 1975 and 2009, displaces approximately 104,000 tons at full load. The Gerald R. Ford class, the Navy's newest and most advanced design, displaces approximately 112,000 tons. These are not numbers that convey their true meaning without reference points. The Ford-class carrier is longer than the Empire State Building is tall. Its flight deck covers approximately 4.5 acres. Its hull alone would dwarf every warship any other nation currently operates. It is not merely a large ship. It is a floating military airbase, a nuclear power plant, a weapons magazine, a fuel depot, an aircraft maintenance facility, a hospital, and a city of approximately 5,000 sailors, aircrews, and Marines, all integrated into a single mobile platform that can reposition anywhere on the globe's oceans in less than 2 weeks. The nuclear propulsion systems that power both the Nimitz and Ford-class carriers use A4W naval nuclear reactors, 2 per ship. These reactors generate the steam that drives 4 propeller shafts through geared steam turbines, producing enough power to drive the ship at speeds exceeding 30 knots, roughly 56 kilometers per hour, while simultaneously supplying electricity to every system on the ship. The nuclear fuel load in these reactors provides a service life of 20 to 25 years without refueling, meaning a carrier can operate for decades without the need to take on propulsion fuel, removing the logistics constraint that limits the endurance of conventionally powered warships. The only consumables that limit how long a nuclear carrier can remain at sea are aviation fuel for the aircraft, food for the crew, and the munitions her aircraft carry to war. The flight deck and aviation infrastructure are the carrier's defining elements. The flight deck of a Nimitz-class carrier is approximately 333 meters long and 77 meters wide at its widest point. 4 catapults launch aircraft from the bow, and 4 arresting wires stretch across the landing area at the stern. On a Nimitz-class carrier, these catapults are the C-13B steam catapult, which uses high-pressure steam from the nuclear reactors to accelerate an aircraft from 0 to launch speed in approximately 2 seconds. The steam catapult system has been in service since the 1950s and is highly reliable, though it requires enormous quantities of steam that imposes constraints on how rapidly sorties can be generated. The Gerald R. Ford class replaced the steam catapult with the electromagnetic aircraft launch system known as EMALS, which uses a linear induction motor driven by electrical energy stored in rotating flywheels to accelerate aircraft down the catapult track. EMALS offers several advantages over steam. The acceleration profile can be precisely tailored to match the specific weight and structural characteristics of each aircraft type being launched, reducing the structural stress on the airframe and potentially extending service life. The system requires no steam, which simplifies the ship's engineering systems and frees the reactors, thermal output for other uses. And the system can be reset between launches more quickly than a steam catapult, increasing the maximum sortie generation rate. The advanced arresting gear, known as AAG, replaced the traditional arresting gear on the Ford class, with an electrically driven energy absorption system that similarly allows programmable recovery loads matched to each aircraft type. The Ford class also introduced a redesigned island. The superstructure housing the bridge and flight control moved further aft on the flight deck compared to the Nimitz class. This repositioning, combined with other flight deck layout improvements, increased the available deck space for aircraft parking and spotting, enabling more efficient aircraft handling and higher potential sortie generation rates. The carrier's design incorporates approximately 23 fewer island-based radars and antennas than the Nimitz class, by consolidating their functions into fewer, more capable systems, reducing topside weight and maintenance burden. The air wing embarked on an American supercarrier is a force of approximately 70 to 90 aircraft representing multiple tactical communities, each contributing a different dimension of the strike group's overall military capability. The core strike element is the carrier air wing's F/A-18E and F Super Hornet squadrons, typically 4 squadrons in a standard air wing. The Super Hornet is a twin-engine multi-role fighter capable of air superiority, strike, close air support, and maritime strike missions. It carries a comprehensive weapon suite including the AIM-120 AMRAAM Beyond Visual Range Air-to-Air Missile, the AIM-9X Sidewinder Short-Range Infrared Missile, the AGM-84 Harpoon Anti-Ship Missile, the AGM-158 Joint Air-to-Surface Standoff Missile, and the full range of precision-guided bombs from the GBU-31 2,000-pound JDAM down to the GBU-53 Stormbreaker small-diameter bomb. The Super Hornet also carries the Advanced Targeting Forward-Looking Infrared Pod, known as ATFLIR, which provides precision targeting, laser designation, and infrared search and track capability for precision strike missions. The EA-18G Growler, operated in dedicated electronic attack squadrons, is the carrier air wing's most important force multiplier. The Growler is derived from the FA-18F two-seat Super Hornet airframe and retains full air-to-air and air-to-ground combat capability while adding the ANALQ-99 tactical jamming system and the more advanced ANALQ-249 next-generation jammer. The Growler's mission is to suppress and destroy adversary radar and communication systems, creating electromagnetic corridors through which the strike aircraft can operate. In Operation Epic Fury, Growlers from both the Lincoln and the Ford provided the electronic warfare suppression that allowed non-stealth aircraft to operate over Iranian territory, and that degraded the tracking performance of Iranian air defense systems against all coalition aircraft throughout the campaign. The Growler is the aircraft that other aircraft cannot function without in a heavily defended environment, and the Carrier Strike Group's organic Growler capability means it does not need to request dedicated electronic warfare support from any external source. The F-35 Charlie Carrier variant brings fifth-generation stealth capability to the Carrier Air Wing, as discussed in the context of the Lincoln's Carrier Air Wing 9 and VMFA 314. The F-35 Charlie's integration into carrier air operations, particularly its longer combat radius compared to the Alpha and Bravo variants due to the enlarged wing and additional internal fuel, makes it a critical asset for deep penetration strikes against heavily defended targets that the Super Hornet cannot safely approach without extensive support. The combination of F-35 Charlie stealth penetrators and EA-18G Growler electronic warfare aircraft in the same carrier air wing creates a synergistic capability where the Growlers suppress the outer rings of an adversary's air defense network and the F-35ers operate inside the inner rings, collecting targeting data and delivering effects in areas the Growlers cannot safely reach. The E-2D Advanced Hawkeye is the Carrier Air Wing's airborne early warning and battle management aircraft. A twin-turboprop aircraft with a large rotodome mounted above the fuselage housing the ANAPY-9 radar, the Hawkeye provides long-range radar surveillance of the airspace and surface environment around the Carrier Strike Group, tracking airborne targets and surface contacts at ranges that substantially extend the strike group's radar horizon beyond what the ship-based radars can see. The E-2D's mission computer processes radar data in real time and fuses it with information from other sensors and data links to build a comprehensive tactical picture that is shared with all aircraft in the air wing and with the ships of the strike group. In the anti-ship missile defense role, the Hawkeye provides early warning of incoming missiles and cues the strike group's interceptor aircraft and ship-based defense systems. In the strike coordination role, the Hawkeye serves as a flying command post that manages the flow of aircraft in and out of the strike area, deconflicts the tactical picture, and relays targeting information between elements of a complex coordinated attack. The helicopter community in the Carrier Air Wing provides anti-submarine warfare, surface search, logistics, and combat search and rescue capabilities through MH-60R and MH-60S helicopters. The MH-60R Seahawk is the Navy's primary anti-submarine warfare helicopter, equipped with dipping sonar, sonobuoys, magnetic anomaly detection, and the ability to carry Mark 50 or Mark 54 lightweight torpedoes for prosecuting submarine contacts. In the waters of the Persian Gulf and the approaches to the Strait of Hormuz, where Iranian submarines, including those damaged but not destroyed in the opening days of the campaign, represented a potential threat to shipping and to American surface combatants, the Seahawk's anti-submarine warfare capability was an essential element of the strike group's force protection posture. The MH-60S provides vertical replenishment of supplies between ships and serves as the combat search and rescue platform, capable of recovering downed aircrew from hostile territory. The surface combatants that form the escort element of a carrier strike group represent in their own right some of the most capable warships ever built. The Arleigh Burke class guided missile destroyer, which constitutes the backbone of the American surface combatant fleet, is a 9,400-ton warship powered by 4 General Electric LM-2500 gas turbine engines, producing a combined 100,000 shaft horsepower, giving it a top speed exceeding 30 knots. It carries a vertical launch system of 96 cells in its standard configuration, each cell capable of holding 1 Tomahawk land attack missile, 1 Standard Missile 2 or Standard Missile 6 surface-to-air missile, 1 SM-3 ballistic missile defense interceptor, or 4 Evolved Sea Sparrow missiles. The specific loadout of each destroyer's vertical launch system is configured to the mission requirements of its deployment. In the context of Operation Epic Fury, the destroyers' Tomahawk magazines provided a distributed precision strike capability that complemented the carrier air wing's strike aircraft. The destroyer USS Thomas Hudner was photographed firing a Tomahawk land attack missile on March 1 in support of Operation Epic Fury, one of many such launches from the destroyers arrayed across the theater. The Aegis combat system is the technological foundation of the Arleigh Burke's multi-mission capability. Aegis was developed in the 1970s in response to the threat of Soviet anti-ship cruise missiles and entered service in the early 1980s. The system integrates the AN/SPY-1 phased array radar, which provides simultaneous multi-target tracking of hundreds of contacts in both the air and surface environments, with the Mark 41 vertical launch system and the weapons control computers that manage the engagement sequence from target detection through missile guidance. The SPY-1 radar's phased array architecture allows the radar beam to be electronically steered without mechanical antenna movement, enabling the system to track multiple threats simultaneously rather than sequentially. The SS system can engage multiple airborne targets simultaneously with different interceptor missiles, managing the engagement sequence of a complex multi-axis attack without saturating the operator's cognitive capacity. The baseline 9 and subsequent Aegis software upgrades have continuously enhanced the system's capability against ballistic missile threats, hypersonic threats, and the saturation attack scenarios that adversaries including Iran have studied and attempted to employ. The Standard Missile family is the primary long-range air defense weapon of the Aegis-equipped destroyers and cruisers. The Standard Missile 2 medium range, known as SM-2, has been in service since the 1980s and provides terminal defense against anti-ship missiles and aircraft at ranges extending to over 150 kilometers. The Standard Missile 6, known as SM-6, extended the SM family's capability to over 300 kilometers and added terminal homing using active radar, giving the missile the ability to engage targets beyond the radar horizon of the launching ship by receiving mid-course guidance from E-2D Hawkeyes or other over-the-horizon sensor platforms. The SM-6 also has an anti-surface mode that allows it to engage surface targets including fast attack boats at range, and a ballistic missile defense mode for engaging short and medium-range ballistic missiles in their terminal flight phase. The Standard Missile 3, known as SM-3, provides ballistic missile defense against medium and intermediate-range ballistic missiles by intercepting them above the atmosphere in the mid-course phase of their flight, well before they can maneuver to defeat terminal defenses. The THAAD Terminal High Altitude Area Defense System, deployed to several Gulf states as part of the American military presence in the region, provided an additional layer of ballistic missile defense complementing the Aegis systems on the destroyers. THAAD intercepts ballistic missiles in the terminal phase of their flight, at altitudes between 40 and 150 kilometers, filling a coverage gap between the SM-3's exo-atmospheric intercepts and the lower altitude SM-2 and Patriot intercepts. The combination of Patriot batteries operated by American forces and Gulf state partners, THAAD, shipborne SM-3, SM-6, and SM-2, and the fighter aircraft providing combat air patrol, created a multi-tier missile defense architecture that absorbed Iran's sustained ballistic missile and drone offensive throughout the campaign. The nuclear submarines that operated in support of the carrier strike groups in Operation Epic Fury represent one of the most capable and least visible elements of American maritime power. The Virginia-class fast attack submarine is the Navy's current frontline attack submarine, a 7,800-ton platform propelled by a single S-9G nuclear reactor. The Virginia-class carries a weapon suite of Mk-48 advanced capability torpedoes and a vertical launch system of 12 Tomahawk cruise missiles in its earlier flights, expanded to 28 Tomahawks in the payload modules of the Block 5 Virginia payload module variant. The submarine that sank an Iranian warship with a single Mark 48 torpedo in early March demonstrated that American fast attack submarines were actively engaged in the maritime campaign, hunting Iranian surface vessels that had not been destroyed by airstrikes. The specific submarine and its identity were not disclosed, consistent with normal American practice of protecting the operational security of submarine movements and employment. The Tomahawk land attack missile is the weapon that links the carrier strike group's surface and submarine elements most directly to the strategic bombing campaign against Iranian targets. The Tomahawk Block V, the current production variant, uses GPS guidance combined with terrain contour matching and digital scene matching for terminal accuracy measured in meters. It has a range exceeding 1,600 kilometers in its standard configuration, allowing it to reach targets deep in the Iranian interior from ships positioned in the Persian Gulf, the Arabian Sea, or even the Red Sea and Eastern Mediterranean. Each destroyer in the theater carried dozens of Tomahawks in its vertical launch system, and the aggregate Tomahawk capacity of the surface force operating around the carrier strike groups represented a strategic strike reserve that could be allocated against high-priority time-sensitive targets within hours of their identification. In the first day of Operation Epic Fury alone, Tomahawks from American destroyers and submarines contributed to the destruction of over 1,700 targets across Iran. The carrier strike group's logistics and sustainment architecture enables it to remain at sea for extended periods without returning to port, sustaining the kind of operational tempo that Operation Epic Fury demanded. The Combat Logistics Force, centered on Lewis and Clark-class dry cargo ships and Henry Kaiser-class oilers, conducts underway replenishment operations that transfer ammunition, aviation fuel, food, spare parts, and other supplies to the carrier and its escorts, while all ships remain underway. The carrier itself holds an enormous onboard inventory, including an aviation fuel capacity of approximately 3 million gallons, sufficient to sustain intensive air operations for several days before replenishment is required. The underway replenishment system uses a combination of high lines for cargo transfer and fuel hoses for fuel transfer, all executed while both ships maintain parallel courses at speeds of around 12 to 15 knots. The Ford-class's redesigned weapons elevator system, using electrically driven elevators rather than the older hydraulic systems, significantly increases the rate at which aviation ordnance can be moved from the magazine to the flight deck, directly enabling higher sustained sortie generation rates. The story of how the carrier strike group became the primary instrument of American maritime power is inseparable from the story of carrier aviation itself, which began in the interwar years of the 1920s and reached its defining moment in the Second World War. The concept of using aircraft carriers as the primary strike platforms of a naval force, rather than as support vessels for battleships, was not universally accepted before the war. Naval orthodoxy in the major powers held that the battleship, with its heavy armor and large-caliber guns, was the decisive weapon of naval combat. Aircraft carriers were seen as useful supporting platforms for reconnaissance and fighter protection, but the idea that they would supplant the battleship as the capital ship of a modern fleet was not mainstream thinking in any navy in 1939. The United States Navy's first aircraft carrier, USS Langley, was commissioned in 1922 as a conversion of the collier USS Jupiter. Langley was a modest platform by later standards, limited in speed and aircraft capacity, but she served as the laboratory for developing the techniques and doctrine of carrier aviation that would be refined over the next 2 decades. In the early 1930s, the Navy commissioned the Lexington-class carriers USS Lexington and USS Saratoga, conversions of battlecruiser hulls left incomplete by the Washington Naval Treaty of 1922, which had limited battleship and cruiser construction among the major powers. These ships were large, fast, and capable of operating substantially larger aircraft complements than the Langley, and they became the foundations of the carrier aviation community's emerging doctrine. The Yorktown class, commissioned in 1937 through 1941, represented the first American carriers designed from the keel up as fleet carriers rather than conversions. USS Yorktown, USS Enterprise, and USS Hornet were purpose-built to a design optimized for the carrier aviation mission, with larger flight decks, better island arrangements, and improved aircraft handling facilities. The Enterprise, commissioned in 1938, became the most decorated American naval vessel of World War II, earning the nickname the Big E, and demonstrated throughout the Pacific Campaign the decisive power of carrier aviation against both surface ships and shore-based targets. December 7, 1941, the Japanese attack on Pearl Harbor simultaneously destroyed the American battleship fleet at anchor and demonstrated the decisive superiority of carrier aviation over the battleship as a naval offensive weapon. The Japanese strike force that attacked Pearl Harbor consisted of 6 fleet carriers operating over 400 aircraft, and the damage it inflicted in less than 2 hours on the American battle line, sinking or disabling 8 battleships, was more destructive than any surface gunnery engagement in history. Conversely, the 3 American fleet carriers that were not present at Pearl Harbor, Enterprise, Lexington, and Saratoga, survived intact and became the core around which the American naval recovery was built. The Battle of the Coral Sea in May 1942 was the first naval battle in history in which the opposing surface forces never came within sight of each other. All offensive action was conducted by carrier aircraft striking targets beyond the horizon. This engagement, followed by the Battle of Midway in June 1942, confirmed that the carrier had supplanted the battleship as the decisive naval weapon. At Midway, American carrier aircraft sank 4 Japanese fleet carriers, the core of the force that had struck Pearl Harbor 6 months earlier, in a single day of combat. The Japanese lost their offensive carrier capability and never recovered it. The Battle of Midway is considered one of the most consequential naval engagements in history, and it was decided entirely by aircraft operating from carriers that never came within gun range of the enemy. The carrier aviation doctrine that emerged from the Pacific War established the framework for how American carriers would be employed for the next 80 years. The Fast Carrier Task Force, which grouped multiple carriers together with a screen of cruisers and destroyers for mutual defense, proved capable of projecting offensive air power against targets hundreds of miles from the fleet, while defending itself against air attack through fighter combat air patrol. The principle of using the carrier as a mobile air base that could be positioned anywhere accessible to the ocean, projecting air power against land and sea targets without the constraints of fixed land-based basing, became the foundation of American naval strategy. The post-World War II era brought the challenge of adapting carrier aviation to the jet age and the nuclear environment. Early jet aircraft, with their higher approach speeds and longer takeoff rolls, created challenges for the existing straight-deck carriers that had served well for propeller aircraft. The British Royal Navy's development of the angled flight deck in the early 1950s solved the core problem of straight-deck operations. On a straight deck, an aircraft that missed the arresting wires on landing would crash into aircraft parked forward on the deck. The angled deck, positioned at an angle of roughly 9 to 13 degrees off the ship's centerline, allowed a landing aircraft that missed the wires to simply advance the throttle and fly off the angled deck without risk to the aircraft or equipment ahead of it. The mirror landing system, also a British innovation adopted by the American Navy in the mid-1950s, replaced the landing signals officer's waving paddles with an optical system that gave the approaching pilot a continuous visual indication of whether his glide slope was correct, improving the precision and safety of carrier landings. The steam catapult, developed in Britain and adopted by the American Navy in the early 1950s, replaced the earlier hydraulic and flywheel catapult systems, with a more powerful and more reliable mechanism capable of launching the heavier jet aircraft that were replacing propeller planes. The combination of the angled deck, the steam catapult, and the mirror landing system transformed the carrier into a platform capable of operating high-performance jet aircraft safely and at operationally meaningful sortie rates, and these innovations defined carrier aviation for the next 60 years until EMALS replaced the steam catapult on the Ford class. The Forrestal class, commissioned beginning in 1955, was the first class of American carriers designed from the outset for jet aviation, incorporating the angled deck and steam catapult from the beginning of the design process. The Forrestal class ships were also the first American carriers to displace over 70,000 tons, establishing a trend toward larger and larger carriers that has continued through the Ford class at over 112,000 tons. The Kitty Hawk class followed in the early 1960s, and the Enterprise class, with USS Enterprise designated CVN-65 and commissioned in 1961, introduced nuclear propulsion to the carrier fleet. Enterprise was the world's first nuclear-powered aircraft carrier and the largest warship ever built at the time of her commissioning, with 8 E-2D nuclear reactors and a flight deck longer than 3 football fields. Her commissioning demonstrated that the combination of nuclear propulsion and jet aviation created a carrier capable of operating at high speed for virtually unlimited range without the need for fuel, a capability that transformed the strategic mobility of carrier-based air power. The Nimitz class, the ships that carried the strike groups that have fought America's wars from 1975 through the 21st century, represented the maturation of the nuclear carrier design. 10 ships were built over a span of 34 years, with each successive ship incorporating lessons from the previous one. The class was named for Fleet Admiral Chester Nimitz, the Commander-in-Chief of the United States Pacific Fleet throughout most of World War II, who perhaps more than any other American naval officer shaped the doctrine of carrier aviation that his namesake ships embody. The Nimitz-class ships displaced approximately 104,000 tons, carried approximately 70 to 90 aircraft, and used 2 A-4W nuclear reactors, producing a total of about 260,000 shaft horsepower. They were designed for a service life of 50 years, which means that USS Nimitz herself, commissioned in 1975 and the first of her class, is now over 50 years old and scheduled for decommissioning, while the last of the class, USS George H.W. Bush, commissioned in 2009 and currently deploying to the Iran campaign, will not reach the end of her design service life until approximately 2060. The Gerald R. Ford class represents the most fundamental redesign of the American carrier since the Forrestal class introduced the modern carrier configuration in the 1950s. The Ford class incorporates not just EMALS and AAG, but a completely redesigned internal arrangement that reduces the number of personnel required to operate the ship from the Nimitz class's approximately 5,600 to approximately 4,500, reflecting advances in automation, systems integration, and maintenance technology. The reduced manning requirement has significant operational benefits in terms of habitability, workload distribution, and the ability to sustain high operational tempo without crew fatigue becoming a limiting factor. The Ford class's power generation capacity, driven by 2 A-1B nuclear reactors that produce 3 times the electrical power of the A-4W reactors in the Nimitz class, is specifically designed to accommodate the electrical power requirements of future directed energy weapons, advanced radar systems, and other high-power technologies that will define naval warfare in the coming decades. The Ford's AN/SPY-3 dual-band radar, which combines an X-band active electronically scanned array for terminal air defense and surface search with the AN/SPY-4 volume search radar operating in S-band, provides the ship with an integrated radar architecture that covers all threat scenarios, from low-altitude sea-skimming missiles to high-altitude ballistic missiles to surface contacts, all managed through an integrated fire control system that automatically cueing weapon systems against threats as they are detected and classified. This automated threat response capability is critical in the saturation attack scenarios that adversaries like Iran have designed their offensive strategies around, where the goal is to overwhelm defensive systems with more simultaneous threats than human operators can manually engage. The Carrier Strike Group as an integrated fighting force has evolved over the decades, from the carrier battle group concept of the Cold War, which positioned the carrier as the protected asset at the center of a large defensive formation, to the modern carrier strike group concept, which positions the carrier as the hub of a distributed, multi-domain offensive force. The Cold War carrier battle group typically included 1 or 2 cruisers, 2 destroyers, 2 frigates, 2 attack submarines, and a logistics ship, arranged to provide layered defense against Soviet anti-ship cruise missiles, submarines, and aircraft. The post-Cold War carrier strike group replaced the cruisers and frigates with additional destroyers and shifted the operational emphasis from defensive protection of the carrier to offensive power projection against a range of adversary capabilities. The integration of nuclear submarines into the carrier strike group concept evolved through the Cold War as the threat from Soviet attack submarines became the primary naval challenge. American fast attack submarines operating in support of carrier strike groups served to sanitize the operating area ahead of the group's track, intercepting Soviet submarines before they could get into attack position against the carrier. The same submarines also carried Tomahawk cruise missiles, adding long-range precision strike capacity to the strike group that complemented the carrier's air wing. The concept of the carrier strike group as a multi-domain offensive force combining carrier aviation, surface combatant fires, submarine launch missiles, and electronic warfare from the Growler became the template for how American carrier-based power was projected through the 1990s and into the 21st century. The Carrier Strike Group has been tested in every major American military operation since the Gulf War of 1991. In Desert Storm, 6 carrier battle groups deployed to the Persian Gulf and Red Sea, their air wings flying thousands of combat sorties against Iraqi targets across the first 5 weeks of the air campaign. The carrier air wings contributed significantly to the destruction of Iraqi air defenses, the attrition of the Iraqi Air Force, and the interdiction of Iraqi ground forces in Kuwait and southern Iraq. The performance of carrier aviation in Desert Storm, particularly the ability to generate high sortie rates from at-sea platforms positioned outside the range of Iraqi coastal missiles, validated the carrier's utility in the post-Cold War conventional warfare environment. Subsequent operations in Bosnia, Kosovo, Afghanistan, Iraq, Libya, Syria, and Yemen all employed carrier strike groups and carrier aviation as central elements of American power projection. In each case, the carrier's ability to position in international waters without requiring access negotiations with neighboring states, its capacity to conduct sustained air operations around the clock, and its integrated air defense and strike capabilities provided military options that land-based aviation could not replicate with the same degree of strategic flexibility. The carrier's independence from land basing is not merely a logistical convenience. It is a strategic and political asset that allows the United States to project force without requiring the permission or the domestic political acquiescence of the governments of neighboring countries, a consideration that became operationally significant in Operation Epic Fury, when Spain declined to grant American forces access to air bases at Rota and Moron, limiting the utility of those facilities while the carrier-based assets continued operating without constraint. The future of the carrier strike group faces challenges from the proliferation of long-range precision strike weapons, hypersonic missiles, and advanced submarine forces that are designed specifically to threaten carriers at ranges that previously seemed safe. China's DF-21D and DF-26 ballistic missiles, sometimes called carrier killers in media coverage, are specifically designed to engage carrier-sized targets at ranges exceeding 1,000 and 4,000 kilometers respectively, potentially threatening carriers operating anywhere in the Western Pacific. Russia's hypersonic weapons, including the Kinzhal, present a terminal phase threat that exceeds the engagement capability of current interceptor missiles. These threats have driven investment in new countermeasures, including longer-range air defense interceptors, directed energy weapons in development for future Ford-class ships, improved electronic warfare systems, and greater dispersion of the strike group's ships to complicate multi-axis attack geometries. The carrier's defenders argue that the threat exaggerates the vulnerability. Destroying a carrier in combat would require a coordinated multi-weapon attack using weapons that must first survive the strike group's layered defenses, including combat air patrol, SM-3 and SM-6 long-range interceptors, close-in defense systems, electronic warfare, and the submarine sanitizing the threat environment around the group. The probability of any realistic adversary salvo penetrating all of these layers simultaneously and achieving a hit on the carrier itself is substantially lower than the threat narrative suggests, and the investment required to achieve that capability would expose the attacking nation to American retaliatory capabilities that far exceed the value of any single ship. As the Iran campaign entered its 7th week, with 3 carrier strike groups either on station or en route to the CENTCOM area of responsibility, with mines being cleared from the Strait of Hormuz by American destroyers and unmanned systems, and with American and Iranian negotiators in Islamabad discussing the conditions for reopening global oil transit, the carrier strike group had demonstrated once again that it remains the dominant instrument of American sea power. 2 carriers had provided the sustained strike capacity that made the largest air campaign in a generation possible. A third was arriving to sustain that presence. Their aircraft had penetrated the most defended airspace in the Middle East from opening night to closing day. Their surface combatants had destroyed Iran's naval forces and were methodically clearing the mines that threatened the global economy. Their submarines had sunk an enemy warship for the first time since the Second World War, and their presence, their sheer mass and power, and the knowledge in every Iranian command post of what they were capable of had been one of the most important factors in bringing Iranian representatives to a negotiating table in Pakistan. The carrier strike group that steamed toward the Strait of Hormuz in the spring of 2026 was not the same institution as the carrier battle groups of the Cold War. It was not the same force that launched strikes on Iraq in 1991. It was the product of 80 years of continuous development, operational experience, technological refinement, and doctrinal evolution, built on the foundation of lessons learned from every engagement, from Coral Sea and midway through Desert Storm and Iraqi freedom to the present conflict. It is the most capable conventional military force in human history, and the events of 2026 have demonstrated, in the most definitive operational terms available, that the reports of its obsolescence were, as they have always been, premature. To appreciate the full depth of what the Carrier Strike Group brought to Operation Epic Fury, it is worth examining the specific tactical and operational contributions of each element in greater detail. The Carrier's air wing is not a monolithic strike force. It is a precisely balanced collection of communities, each with specialized training and equipment, designed to function together in a way that produces capabilities no single element could generate alone. The relationship between those communities and how they work together inside the theater of a major campaign tells the story of how American carrier aviation evolved from the ad hoc arrangements of World War II into the tightly integrated operational architecture that flew over Iran in 2026. The F/A-18E and F Super Hornet community provides the bulk of the air wing strike capacity and the majority of its air-to-air combat power outside the stealth envelope. The Super Hornet entered service in the late 1990s as a replacement for the older F/A-18C and D Hornet and the F-14D Tomcat, and it represented a substantial improvement in range, payload, and avionics capability over the aircraft it replaced. The E model is the single-seat variant, optimized for a single-pilot precision strike and air superiority missions. The F model is the two-seat variant, with the second cockpit occupied by a weapons systems officer who manages the more complex sensor and weapons employment tasks that benefit from a dedicated second crew member. Both variants share the same AN/APG-79 AESA radar, the same advanced avionics suite, and the same weapons compatibility, though the F model is often assigned the most complex missions, including missions requiring dedicated sensor management, electronic warfare integration, or weapons employment sequences that would challenge a single pilot's workload. In Operation Epic Fury, Super Hornets from both carriers flew thousands of combat sorties against Iranian targets, operating in the outer threat rings, where the electronic warfare support of the Growlers had created electromagnetic corridors of relative safety. They carried JDAM-equipped bombs against fixed infrastructure targets, Harpoon missiles against the Iranian naval vessels that were threatening tanker traffic in the strait, and long-range JSM cruise missiles against high-value targets at ranges that kept the aircraft outside the most dangerous engagement zones. The Super Hornet's AN/APG-79 radar provided targeting quality tracking of surface contacts, allowing crews to identify and engage fast-attack boats and mine-laying vessels at ranges that the aircraft's weapons could prosecute with high confidence. The tanking mission, conducted by Super Hornets configured as aerial refueling aircraft using the external buddy store tanking system, is one of the less visible but absolutely critical contributions the carrier air wing makes to its own sortie generation capacity. When a carrier is conducting sustained strike operations at the rates demanded by a major campaign, the distances between the carrier and the targets, combined with the fuel consumption of jet aircraft at combat power settings, often mean that aircraft would have to turn back before reaching their targets if they could not take on fuel from a tanker somewhere along the route. The carrier has no dedicated tanker aircraft of its own, so it relies on Super Hornets fitted with the aerial refueling store to provide the tanking capacity that allows other Super Hornets and aircraft from other communities to reach targets at the extreme end of the air wing's range and return safely. This buddy tanking mission consumes a meaningful fraction of the air wing sortie capacity, but enables strike missions that would otherwise be impossible from a carrier-centric planning perspective. The E-2D Hawkeyes' role in managing the complex airspace over a major campaign cannot be understated. In the operational environment of Operation Epic Fury, with aircraft from multiple carriers, multiple land-based air forces, allied nation air forces, unmanned systems, and tankers, all operating in overlapping airspace, the challenge of deconfliction, ensuring that friendly aircraft do not interfere with each other and that the right aircraft are directed to the right targets at the right times, was immense. The Hawkeye provided the persistent airborne surveillance and battle management capability that allowed the strike coordinators to manage this complexity. Its radar tracked every aircraft in its coverage area simultaneously, and its mission computer processed the data to maintain continuous awareness of the overall air picture. When a ground-based controller lost contact with an aircraft due to terrain masking or jamming, the Hawkeye typically retained coverage from its elevated position. When a time-sensitive target emerged that required immediate engagement, the Hawkeye could identify which aircraft had the right weapons, the right fuel state, and the right proximity to be retasked to the new mission. The E-2D's cooperative engagement capability, which allows it to share its sensor data with Aegis-equipped surface combatants and other platforms in real time, created a networked air picture that was richer than any single platform could build alone. A destroyer whose own SPY-1 radar horizon was limited by the Earth's curvature could receive over-the-horizon contact data from the Hawkeye and engage targets at ranges far exceeding what its organic sensors could detect. This cooperative engagement architecture is particularly important for the ballistic missile defense mission, where early detection and long tracking time are essential for computing an accurate intercept solution. The Hawkeye's radar could detect a ballistic missile launch from Iran's territory within seconds and immediately begin tracking the trajectory, providing the Aegis systems with enough data to compute and execute an intercept solution before the missile reached the engagement altitude where SM-3 or SM-6 could be effective. The submarine contribution to the Carrier Strike Group in Operation Epic Fury illustrated a dimension of American undersea power that rarely receives the attention its strategic importance warrants. American fast attack submarines had been operating in the waters around Iran for weeks before the campaign began, conducting intelligence gathering, monitoring Iranian naval movements, and positioning themselves to support the opening strikes. The Tomahawk cruise missiles fired from submerged submarines in the opening hours of the campaign came from positions that Iran could not detect, track, or target. Unlike surface combatants, which are visible to satellite reconnaissance and whose approach can be tracked by Iranian intelligence systems, submarines operating below the surface are effectively invisible to all but the most capable anti-submarine warfare systems. Iranian anti-submarine warfare capability is limited, and the operational environment of the Persian Gulf and the Gulf of Oman allowed American submarines to operate in close proximity to Iranian territorial waters with minimal risk of detection. The Mark 48 Advanced Capability torpedo that sank the Iranian warship in early March is a weapon that deserves specific attention. The Mark 48 is a heavyweight torpedo carried by American fast attack and guided missile submarines. It is wire-guided, meaning that after launch it remains connected to the launching submarine by a thin wire through which the submarine can update the torpedo's course and target designation throughout its run. As the torpedo approaches the target, its own active or passive acoustic seeker takes over for terminal homing, following the target's acoustic signature to contact. The Mark 48 ADCAP variant, the advanced capability upgrade that entered service in the 1980s, introduced dramatically improved guidance software, a more powerful warhead, and enhanced resistance to countermeasures. The variant used against the Iranian warship represented the most capable version of this weapon system, and its effectiveness in the engagement validated its design and the operational concept of the submarine as a precision strike platform against surface targets. The mine warfare dimension of the Strait of Hormuz crisis brought to prominence a category of naval capability that receives relatively little attention in peacetime, but that proved strategically consequential in this campaign. Naval mines are one of the most cost-effective weapons in any nation's arsenal. A sea mine costing a few $1,000s can deny a straight-to-shipping worth billions of dollars per day, force the deployment of expensive mine countermeasure forces, delay the movement of military units, and impose psychological costs on commercial shipping operators that can persist long after the physical mines have been removed. Iran exploited all of these characteristics by seeding the Strait of Hormuz with mines in the opening days of the campaign, creating a hazard that proved more durable than the Iranian naval forces that were rapidly destroyed. The American mine countermeasure capability deployed in response, anchored by the 3 Littoral Combat Ships equipped with mine countermeasure mission packages in Bahrain, represented the Navy's primary organic capability for this mission. The Littoral Combat Ship is a controversial platform whose development history has been marked by cost growth, schedule delays, and questions about its survivability and utility in high-threat environments. But for the mine countermeasure mission specifically, the LCS's shallow draft, relatively small size, and ability to rapidly configure with specialized mission packages makes it more suitable than larger surface combatants for operating in the shallow, confined waters of a mine strait. The Mine Countermeasure Mission Package includes the Remote Multi-Mission Vehicle, an unmanned underwater vehicle that can be deployed to search and identify mines using acoustic and optical sensors, the Airborne Laser Mine Detection System carried on the embarked MH-60 helicopter to detect mines from the air using laser-based scanning, and the Airborne Mine Neutralization System for destroying identified mines without exposing human divers. The mine-clearing operation that American destroyers began on April 11 also employed unmanned underwater vehicles capable of mapping the mine field and providing the data needed to plan safe corridors through the contaminated water. CENTCOM confirmed that underwater drones were joining the clearing effort alongside the destroyers, reflecting the broader integration of unmanned systems into naval mine countermeasure operations that has been a priority of the Navy's mine warfare program for the past decade. The mine-clearing operation was ongoing as of April 12, with Iran's admission that it had lost track of some of its own mines, complicating the process. A minefield where the laying nation cannot accurately locate all of the weapons is among the most dangerous categories of the explosive hazard, because it means that neither the mines, original placement records, nor the cooperation of the laying nation can be relied upon to identify all of the dangerous areas. The Allied dimension of the carrier strike group operations in Operation Epic Fury reflected both the strengths and the limitations of American alliance relationships in the Middle East. The Gulf Cooperation Council nations Bahrain, Kuwait, Qatar, Saudi Arabia, and the United Arab Emirates provided critical basing and overflight rights that supported the land-based elements of the campaign, including the air bases from which F-35s, A-10s, and other aircraft conducted sorties into Iranian territory. But these nations were themselves under direct military attack by Iran throughout the campaign, taking missile and drone strikes that killed civilians, damaged infrastructure, and required the redirection of American air defense resources to their defense. The carriers, operating in international waters beyond the direct reach of most Iranian land attack systems, provided a backstop to the campaign's strike and air defense capacity that did not depend on any of these nations' territorial security. The French carrier Charles de Gaulle and its strike group, which entered the Mediterranean Sea on March 6, heading toward the eastern Mediterranean, Red Sea, and Strait of Hormuz, represented the most significant Allied naval contribution to the theater. The French carrier group included several French frigates and Spanish, Dutch, and Italian frigates, a coalition of European naval capability that, while smaller than the American forces, provided meaningful additional strike and air defense capacity and the political signal of broader alliance solidarity with the American campaign. The Charles de Gaulle operates Rafale Marine fighters in its air wing, a capable fourth-generation multi-role aircraft that can conduct strike and air defense missions complementary to the American Super Hornets and F-35s. The French strike group's presence in the theater meant that the American carriers were not operating in diplomatic isolation, even as most American allies declined to send warships to directly participate in the Strait of Hormuz security operations. The economic stakes that surrounded the carrier strike group's operations in the Strait context are worth examining in detail because they represent the ultimate strategic objective of the entire maritime effort. The Strait of Hormuz at its narrowest point is approximately 21 miles wide, with only two shipping lanes of about 2 miles each for inbound and outbound traffic. Through this tiny passage, under normal circumstances, passes approximately 20 million barrels of oil and petroleum products per day, or roughly 20% of global oil consumption. It also carries approximately 1/5 of global liquefied natural gas trade. The nations of the Persian Gulf collectively hold approximately 48% of the world's proven oil reserves, and the vast majority of their export infrastructure points toward the Strait of Hormuz as the only practical maritime exit from the Gulf. When Iran closed the strait in the hours after Operation Epic Fury began, the economic effects were immediate and global. Brent crude prices surged toward $81 a barrel within the first week, a 12% increase, and analysts projected $100 or higher if the disruption persisted. Tankers from the world's largest shipping lines, including Maersk, Hapag-Lloyd, and others, were ordered away from the region. 230 loaded oil tankers sat in the Persian Gulf, unable to exit. Asian economies, particularly Japan, South Korea, India, and China, which depend heavily on Persian Gulf oil imported through the Strait of Hormuz, faced supply disruptions that drove up energy costs and began affecting industrial production. The International Energy Agency launched its largest ever emergency reserve release in an attempt to buffer the supply shock. But reserve releases are by definition temporary measures that cannot substitute for the restoration of normal supply flows. The strategic logic of the United States maritime campaign was inseparable from these economic stakes. Every Iranian fast attack boat destroyed by carrier aircraft was a potential tanker attack neutralized. Every coastal anti-ship missile battery struck by a Tomahawk was a threat to shipping eliminated. Every mine identified and neutralized by American mine countermeasure forces was a step toward the safe transit corridor that global commerce required. The blockade President Trump declared after peace talks initially failed was not merely a military measure. It was an economic lever, threatening to cut off the Iranian oil revenues that funded the government's ability to sustain the war, while simultaneously positioning American naval forces to resume tanker escort operations the moment a political agreement made them feasible. The tanker escort concept that American planners were developing throughout the campaign drew on historical precedents that the United States Navy had actually executed in this same geographic region. During the Iran-Iraq War of 1980 through 1988, Iran had attempted to use naval mines and air attacks to threaten tanker traffic through the Gulf, targeting not just Iraqi oil exports but the shipping of neutral nations. In 1987, Kuwait, facing the loss of its oil export income, requested that its tankers be reflagged under the American flag and escorted by United States Navy warships. Operation Earnest Will, which ran from July 1987 through September 1988, was the largest naval convoy operation since World War II, with American warships escorting reflagged Kuwaiti tankers through the Gulf, while simultaneously engaging Iranian naval forces attempting to disrupt the convoys. The operation involved the sinking or disabling of numerous Iranian naval vessels, the destruction of Iranian oil platforms used as staging bases for fast attack boat operations, and a brief but intensive naval engagement known as Operation Praying Mantis in April 1988, in which American forces sank or damaged 5 Iranian naval vessels, including a frigate, and damaged 2 oil platforms in a single day's fighting. Operation Earnest Will established the precedent for exactly the kind of maritime security operation that American naval planners were contemplating in the Strait of Hormuz in 2026, and the carrier strike groups, positioning in the Arabian Sea and Red Sea, gave them the flexible strike and air defense capacity to support a convoy escort operation on a scale that Earnest Will had not required. The difference between 1987 and 2026 was that the Iranian threat had become significantly more capable in the intervening decades, particularly in the anti-ship missile and drone domains, while American carrier-based air power had also advanced to a degree that the carrier air wings of the Earnest Will era could not have matched. The IRGC's drone carrier, the Irish Shahad Bagheri, a 40,000-ton converted vessel repurposed to operate unmanned aerial systems as a mobile drone deployment platform, was destroyed by American strikes in the Persian Gulf in the first week of the campaign, with CENTCOM releasing video showing 2 direct hits on the vessel. This was a particularly significant targeting decision because it demonstrated American willingness to strike not just conventional naval vessels but the innovative asymmetric assets that Iran had developed specifically to threaten shipping and American forces through drone warfare. The destruction of the Shahid Bagheri removed a mobile drone launch capability that Iran had been developing as a means of extending the range and persistence of its maritime drone threat beyond what shore-based launch facilities could provide. The operational picture that emerged from the campaign was one of American naval power systematically working through the layers of Iran's maritime threat architecture. The long-range threat of shore-based anti-ship missiles was addressed through carrier air-wing strikes that destroyed the launchers and their command and control. The medium-range threat of fast-attack boats and mine-laying vessels was addressed through carrier air-wing aircraft, A-10 Warthogs flying close air support missions against surface targets, and the AH-64 Apaches that provided overwatch and strike capability against small surface threats close to the Iranian coastline. The mine threat was being addressed by the LCS mine countermeasure packages, the destroyers, and the unmanned underwater vehicles. The submarine threat, such as it was given the limited capabilities of Iran's submarine fleet, had been dealt with by the American fast-attack submarines that had been operating in the area before the campaign, and that had already demonstrated their willingness and ability to engage Iranian naval targets with lethal effect. By April 12, the operational situation in the Strait reflected the results of 6 weeks of this systematic campaign. Iran's naval forces had been reduced to a fraction of their pre-war capability. The mines that Iran had sown were being systematically located and cleared. American destroyers were transiting the strait for the first time since the war began, beginning the mine-clearing operations that would establish the conditions for safe commercial transit. 3 oil supertankers had transited the strait in what was described as the biggest day of oil exit since Iran had closed it. The ceasefire was fragile, the peace talks were ongoing, and the full restoration of normal tanker traffic was still weeks away. But the direction of travel, from zero transit to tentative reopening with mine clearing underway and American warships in the strait, was clear. The carrier strike group's contribution to that trajectory was fundamental. Without the Lincoln in the Arabian Sea and the Ford in the Red Sea providing the strike capacity to destroy Iran's naval forces in the first week of the campaign, Iran's ability to threaten tanker traffic with fast attack boats and anti-ship missiles would have remained intact throughout the campaign. Without the carrier air wings flying thousands of sorties against Iranian coastal defenses and missile batteries, the mine-clearing destroyers that transited the strait on April 11th would have faced an intact threat environment that would have made their transit suicidal. Without the Aegis destroyers providing air and missile defense for the carriers and the allied Gulf states, Iran's sustained missile and drone offensive would have imposed far greater costs on the nations supporting the American campaign, potentially fracturing the coalition's political cohesion. The carrier strike group is not a weapon of last resort. It is the primary instrument through which the United States projects military power across the global commons, and its presence in the waters around the Strait of Hormuz was the single most important military factor in the political, economic, and military dynamics of the most consequential maritime crisis since the Second World War. The ships that steamed through those waters, the aircrew that launched from those flight decks night after night, the submariners that patrolled those depths, and the surface warriors that manned the combat information centers of their destroyers in the shadow of Iranian missile launches, all of them were the latest generation of a tradition that goes back to the Pacific War, a tradition of American maritime power projection that has shaped the world's oceans for 80 years, and that the events of 2026 demonstrated still shapes them today.